If you had a balloon, where would it take you?
To the sky.
If you had a balloon, where would it take you?
To Disney World.
If you had a balloon, where would it take you?
To outer space.
If you had a balloon, where would it take you?
To my Nana's house.
If you had a balloon, where would it take you?
To China.
Now that you have a set of responses based on a prompt, you need to see how science, or you need to think about how science weaves its way through those ideas, just like mathematics and just like social studies. Science. A good way to do this is to have a blueprint of the basic ideas of science. Remember, we're dealing at this level with big ideas. We're not dealing with the minutia of memorize this, kid, or I'm going to get fired. That's later on down the road. This is dealing with big ideas, the big ideas of science. And what are the big ideas of science? Because if you can remember a few big ideas, it's easier to have an intelligent conversation. You don't have to memorize a lot of things. You just have to memorize a few key concepts that science is all about. A group of science educators, a group of scientists have come up with this 8+1 concept map of science. And the first three that you see here, what are things made of? Big things are made of smaller things, atoms. Now, even though atoms is where we're going in high school, but right now, little kids, elementary kids, need to know that big things are made of smaller things. That's it. There are a lot of different types of plants and animals, and they have cells, but cells aren't that important at this point. The idea is that there is variability in the world, and that there are plants and animals. And then finally on this particular slide, radiation. The idea that heat and light and even cold move through space. You can feel cold seeping in through the wall of an apartment if there's not enough insulation. Radiation. Radiation is everywhere. So given those three, or given the three that you see in front of you, that's what things are made of. We may not be able to cover those three in a conversation about balloons going to outer space, and yet in some conversation, sometime in the future, you're going to be able to concentrate, focus on those key ideas. The next fundamental concept is this idea of systems, and that systems change, and that we have a smaller system and it works into a bigger system. This may not be appropriate for 5-year-olds. And yet this same approach can be used with older children to engage them in an intelligent conversation about system changes. The next fundamental concept is forces. Changes in the motion of objects are caused by forces. Now here is a great tie-in with our balloon. There are forces at work that change. An easy one to come up with that all children have experienced is the idea of wind, and that wind moves things at varying speeds. And if you wanted to go there, you could use the force of a jet propulsion pack. All kids, or well, let's say the boys love their little Power Rangers or their Rocket Men or their X-Men or their whatever they are, super American heroes, comic book things that are so popular. And how do they move around? They move around with these jet propulsion packs, and they are stronger than the wind, or they're more powerful than the wind, and yada yada. You get the idea. The next fundamental concept is energy. Everything that happens in this world involves some type of energy. Again, this may not be a conversation for 5-year-olds, but it may be a conversation for 10-year-olds. The same approach can be used regardless of age. It's the approach. It's not the content. It's not the specific conversation. conservation of matter and energy. All matter and energy change over time, but they never go away. Matter is neither created nor destroyed. It's just changed in some way. Again, this is not a conversation for 5-year-olds. It's certainly a conversation for upper elementary and on. It's the approach that matters. It's not the conversation specifically about one thing. You're not going to be able to cover all of these things with 5-year-olds because it would be inappropriate, or you may never have the opportunity. Although the concepts that you need to get across to 5-year-olds can be covered in this way, through intelligent conversations. And lastly, variation. And this has to do to genetics, but the idea of variation in anything. And the approach that I advocate in Listen, Move, Think is all about variation. If I change this variable, the weight, it's going to affect other things. For example, let's say I throw in a curveball for these kids, and, if you had a balloon, where would it take you? And then we're talking about distance and time. And then let's say there's 2 of you. How is that going to affect distance and time? Okay, how could I negate the extra weight? You're not going to use the word negate, of course, or you might with explanation. In what ways can I diminish the effect of added weight and get to our ending point, say China, in the same amount of time? And then you have to get into the fact that you can't just float there now. You have to actually be propelled, and what kind of propulsion would be the best way to go. These are the types of intelligent conversations that will not help your children memorize the multiplication table, and yet they will do something far more important. Get them to deal with, to consider variability. Critical thinking is handling variability in a way that will help children think. Variability. Constants are not as important to critical thinking as variability is. What if? As you listen to these videos, you're going to hear a lot of what if, if then, if then. If this happens, logically, this happens, or this is impacted somehow. If the if changes, then the then changes.